what I really need is I got to figure out some way to like put the back on and secure the whole thing all at one time.
Couldn't couldn't you just do, like, a clamshell and then a latch?
Hey, YouTuberverse, this is Jason Newman, and we're going to do the disembodied voice format for this video. I wanted to do a follow-up about the making of the back that I implied in a previous video, and this is it. For when I was making this video, where I live, we got hit with a wicked, unseasonable cold front in the winter. So I had to move my project into one of the smaller rooms in my house. So this is the game room. And because the chemicals that I use, they don't really enjoy were being outside of something close to 70 degrees. So my workshop wasn't going to work. Anyway, so here we are. And my buddy Bobert gave me this idea of using some sort of a quick clamshell with a latch. And I was looking at my toolbox and I didn't want to use something that was a clamshell because as you pour the foam and then you close the lid on one side, it'll push all the foam to the other side. I wanted something that was more like a hydraulic press I could just drop straight down on top of and lock all at once. And I'm looking at the toolbox and I noticed the type of latches that it has, and it gave me this idea. But let's stop here for just a minute because as I started to work on this problem that I had with the back, I started to notice other problems that I was having with the backs. So this is the edge of the shield that I take to charity events where I let everybody who wants to hold the shield can hold the shield. So you can see it's starting to separate from the metal disc. This is the Sam Wilson shield, and there's a lot of damage. There's separation. Even when I do a good job, so here I get right there, you see these little kind of like bubbles along the edge. That's coming, I think, from the seam. It's just not as good as I want it to be. I kind of went down a little bit of a rabbit hole and I overhauled the entire process that I make the back from. But let's just start at the beginning. These are the load-bearing parts. In the Captain America community, everybody loves JB Weld, and JB Weld is great. You've seen videos in the past where I make a mountain of JB Weld over top of each one of these T-nuts. Am trying a new adhesive that I learned about, Infinity Bond MMA 420 plus. These things get handled, and there's vibration that happens. Vibration goes into the JB Weld. JB Weld becomes brittle, even though it has a extremely high tensile strength. It's more this stuff. It's incredibly strong in its own right, but it withstands vibration. This stuff will absorb the shock. So in performance, the way that people use these shields, this, I believe, is going to outperform JB Weld. This also sets up a lot quicker than JB Weld does. So in 20 minutes, all of this should be handleable. And then I'm going to put the mold on top to make sure they line up where they should be. If everything is as it should be, I'm going to put a mountain of the 420 on top of all of them. Another interesting thing, even though I did scuff this all up in prep for, I always do that, that'll give the foam something to hold on to, but apparently this stuff is a self-etcher on metal. You don't have to rough up the metal. Roughing up the metal doesn't hurt, but apparently this does the job. So sets up quicker, less prep time. All right, it has been about 24 hours. This is all cured. It is strong. I can't even put a fingernail dent in it. So all of this is what is load bearing and enables you to hold the shield by the straps. Yeah, so next up, I'm gonna build the thing that is the actual shape of the back, which will take a while, but that is what's next. Okay, so to make the shape of the back, the first thing that we're gonna need is we're gonna have to put the coat that is like the beauty coat shell, and I have landed on through trial and error EpoxaCoat by Smooth-On. You can see right now I'm just mixing part A. Anytime that these have been sitting on the shelf for a while, whatever product you're using, you're going to want to give it a nice shake or stir. So that's what I'm doing right now. We're going to jump around in time a little bit because we're going to do 4 coats and each round takes about 15 minutes. So let's speed this up a bit. One of the things about EpoxaCoat is it has a really wide, different mix ratio. It's 100 parts of part A to 15 parts of part B. So you get this real big container of part A and this itty bitty container of part B. And in my case, right now, I am measuring out exactly 150 grams of part A. And this right here, this is one of the new things that I'm trying out with this back that worked really well. It's Smooth-On's Flexer Flexibilizer. Say that 5 times quick. Since EpoxaCoat has a Sure Hardness rating of 85D, which it puts it somewhere in between like a construction worker's hard hat and like human bone. The thing is, it doesn't really handle shock very well. Now, nothing's really going to save one of this shield if it gets dropped, but still, dinging it against something, just picking up and handling it, it rattling around in the trunk of the car, all these little vibrations take its toll over time, and this makes a product somewhat more elastic and shock absorbing. So the way that I do this is I mix a 10% of the part A solution into part A only. So in this case, it'll be 15 grams of the Flexer Flexibilizer. At this point, the clock isn't ticking. You just want to make sure you get a real thorough stir. I end up stirring this for something like 2 minutes, and I'm using a flat edge popsicle stick so that I can scrape the bottom. And that's basically it. Right now, I could do this all day. I don't know what happens if I leave it for like an hour, but I have no intention of doing that. So after about 2 minutes, I feel confident I have a thorough mix. Now here comes the EpoxaCoat Part B. For my case, I'm going to be using about 23 grams. And once it touches the EpoxaCoat, the clock starts ticking. So I'm going to do, as I said, 4 different rounds of this. And you might be wondering, why not just do one big round? And the reason is because this stuff is, I think it's called thermogenic. It basically, once they mix, they generate heat. The more of it that's together, the more heat it generates. One time I did put that entire small bottle inside that entire big container, and it got so hot that I thought it was going to ignite. I had to set it outside and just wait for it to finish reacting. So small batches, but lots of them. And I mix for exactly 3 minutes. Before I do anything, I also want to point out this is another new part of the process, because in the past, when I would put on the mixed EpoxaCoat, the holes that the screws have to go through, the EpoxaCoat would start to run through that. And I didn't really know what to plug it up with. I have tried various things, nothing really worked. And if you saw in a previous video, some of the EpoxaCoat will sometimes get on, it will be stuck in those holes and make it a nightmare to separate. So I found something called Monster Clay. Monster Clay is a fantastic, they use it for movies. I think it's the clay whenever you see somebody making a mold of a face or something, they would be using this clay. It's reusable. I mean, you always lose a little bit of material whenever you use it, but for the most part, overwhelmingly, most of that can be balled right back up and reused again. So I have plugged up each of the holes with Monster Clay, and then because I don't want the EpoxaCoat to reach the edge, I have created a wall. You'll see later why I don't want it to reach the edge. And this is fairly straightforward. With a chip brush, I'm just kind of pushing it off of my plate right into the center, and then I'm gonna smooth around and try to make sure it gets into those overhangs and all those crevices, and that'll be that. And you could see this first round, this really doesn't cover all that much. It barely does almost anything, but we're going to do it again. And here we are. This is round two. It is literally exactly the same thing as round one. So you could just rewatch round one, I guess. And here we are back on the mold, and I'm pouring it on and smoothing it out. And you can see it does better, but we're still nowhere near enough to cover the surface. Round three, there's more part A of the EpoxaCoat, more Flexer Flexibilizer, more part B, mix it all thoroughly. And now we're going to start to get full coverage. But if I stopped here, it would end up being like paper thin, maybe even less than paper thin. So we're going to end up doing one more final round of this to make sure it achieves some level of thickness. Round four, part A, mix in the flexibilizer, mix in the part B, get a thorough mix. And here we are, the fourth and final coat of the thoroughly mixed EpoxaCoat. This will achieve full coverage. It'll give us a nice shell. In the past, I used to do 5 coats to make sure the shell was really thick, but I don't need it to be really thick right now because for this one, going for this shield, I'm going to end up incorporating fiberglass. So you'll see me set that up next. But for now, I'm going to let this sit and do its thing for roughly about 3 hours. After that, I'm going to check on it to see if it is in the green stage. And I will explain what that is in a few minutes. While the epoxy coat cures, I'm going to end up working on prepping for the fiberglass stage. I'm using 4-ounce plain weave fiberglass cloth. And I'm doing this because chop strand doesn't really work for my purposes. I've seen some prop makers on YouTube who use chop strand. It's not the greatest for this, and I'm not using 6-ounce or 8-ounce cloth because in this case, double the thickness is not exactly double the performance. By using 4 ounces instead of 8 ounces, I can cut 2 circles and then rotate one of them 45 degrees, which offsets the fibers, which reinforces the fibers. Hence the 4 ounces, and why I'm doing all of this 2-circle tracing and cutting. And here we are back with the mold, which has been sitting there for about 3 hours. I don't remember exactly what the time was, but I started to check on it at the 3-hour mark. And what I'm looking for is I have the gloves on, and when I touch the side, here we go. What I'm looking for is for it to feel like stickiness, like a post-it note. It shouldn't come up onto my glove, which it right there did not. And I should leave a fingerprint in the still curing resin. So I'm just checking again. And what the green stage is it's this sweet spot in between while the chemical reactions are happening. I can now bond the fiberglass to the resin as it's in this green stage. If I put it on too soon, it's just going to be liquid. It's not really going to work. It'll probably delaminate later. If I put it on too late, it would just be laying a sheet over a hard rock that I have to rough up so that the resin can get some tooth on it. But right now, we are in the perfect spot where, on a chemical level, they will bond together. So here we go. I'm going to lay the first of the 2 fiberglass sheets over top of this. And admittedly, I got better at this the more times I tried it. But on this one, I didn't realize once you put it down, it's there. So it's always a good idea to record you doing the first of anything, right? So this one has more bubbles than I would like, but they all can be dealt with later. And laying the second one on top is very easy. You just lay it on top. But the important thing to note is make sure that the fibers are rotated 45 degrees, not 90 degrees, because these are woven in kind of square pattern. So if you rotate at 90 degrees, all of the fibers are going to be, again, in alignment. 45 degrees, they're out of alignment halfway, which makes it perfect for structural reinforcement. So for fiberglass to work, you need to wet it out with some kind of a resin. The resin that a lot of people like to use is Bondo, but first thing, I really like using EpoxaCoat, and Bondo fiberglass resin does not work with EpoxaCoat. You have to use a different type, and it's a benefit for me because I did use Bondo fiberglass resin one time, and I had no idea how insanely toxic smelling that stuff is. I don't ever want to use it again. So I ended up researching and finding West System 105. This stuff does work well with EpoxaCoat. And you use the 206 hardener, which gives it a really long work time. But West Systems, the 105, you mix in a ratio of 5 to 1. In my case, it's going to be a 114 grams total mix with 95 grams of the 105. This is going to end up honestly being way too much resin, but until I get my process dialed in, I would rather have way too much resin than not enough resin. And for the part B, it would be the 206 hardener. For that, I'm going to use 19 grams. And make sure you mix it very thoroughly. I'm going to mix it for 2 to 3 minutes with a flat stick to make so that I can scrape the bottom and the sides. And here we go, putting the resin on both sheets of the fiberglass. This whole process is about 20 minutes sped up, but you can see once you get going, it wets out the fiberglass really well, holds it in place, and I have plenty of resin left over. So going forward, I might cut this down by maybe 25%, maybe a third. Here we are 24 hours later, and let's take a look at this thing. So one thing that I do want to make sure I mention was I forget to point out, I before doing any of this, I did coat the mold in Ease Release 200. If I had not done that, this demolding would have been a very different experience. So normally what happens is I have to really fight to get this thing off of the mold, and because there's some sort of overhang issue. And I think because I plugged up those holes with the monster clay, you'll see this comes off very easy. Voila. All I really needed to do was break the vacuum seal between the mold and the cast. This was the easiest one ever. Remember when I said that monster clay is reusable because it doesn't dry out? So right now I'm going to go get all that monster clay back. I mean, I don't want to waste materials. This stuff all gets expensive. And now we just do a quick removal of the excess fiberglass cloth. And my lack of camera angle awareness notwithstanding, this is me opening up the holes so that the T-nuts can go through. So you might be wondering, well, Jay, you haven't done the foam yet. Now that you're putting holes in the shell, isn't the foam just going to get out through those holes? Not to worry, I have a plan for that. This whole overhauling of how I make the backs all started because I wanted to try to get to the bottom of the separation from the resin from the aluminum disc. So the idea I have in mind, instead of fighting with it, I am on purpose going to make sure the resin does not meet the aluminum disc. You'll see how I address it coming up. But right now, to make sure that the resin does not meet the edge, I need to know where the edge is. So I'm marking the edge with the cheapest red lipstick I could find at the grocery store. So one option would be I could just put the shell down on top, fill everything with foam, and then there'll be the resin shell resting on top of the disc. And when I sand down the edges, everything will be fine and be nice and flush. But when you get real close to look, you'll see a seam where the resin and the aluminum disc are. Not the worst thing, it's just not what I want. And sand down until I don't see the red line anymore. Now that I've made sure that the edge of the resin doesn't meet the edge of the disc, I'm getting ready to put the foam in. In the past, I would put the foam in while the resin was in the green stage, but now that we have the fiberglass step, that part's out. The foam not only gives structural integrity, but it also marries the disc to the shell. So I want this to have a very good hold. I scuffed up the inside of the disc so that the foam can get a good grip to it, but I did not scuff up the inside of the shell, which is what I'm doing right now. After cleaning the cast and the disc, I put tape over the T-nuts to make sure the foam doesn't get inside. So now we're going to go into the foam process and make sure you stir this before you use it. The reason is because this product is all about expansion. You want that stuff to be really loosened up. So the shield is 24-inch wide by about half an inch thick. If it was all metal, it would weigh something like 20 pounds. To reduce the weight, the core is made out of a rigid foam. The lightest foam that I was able to find that's usable for this project is Smooth-On's Foam at 3. So I'm trying to fill about 190 cubic inches. Foam at 3 expands 16 times its volume once it's mixed. So I'm going to mix roughly a little more than 12 ounces of this stuff total. Right now, I'm measuring out 6.47 ounces of part A. And now I'm measuring out 5.63 ounces of part B. I could just do a 1-to-1 mix ratio and mix 6 ounces of part A and 6 ounces of part B, but I used the calculator on the Smooth-On website, and this is what it calculated, and I like to be as precise as possible. So going back to the idea that my buddy Bobert gave me, and after I found these latch hooks, I knew that they would need something to grab onto. So I designed this. I only needed to design the one side and then print it 4 times. And JB welded it all together so it's nice and secure. And then I also purchased one of those shoe patch leather sewing machines, which have horrible legs for it to stand on. Well, I took those off and recut them and repurposed them for this. And this actually makes a really good holder for the shield. The cloth is just there for cushioning, but also to add a little bit of extra dimension for when the latches pull, they have something to really pull against. I'm just doing a one final premix of each part before mixing them both together. So once you start mixing it, you are on the clock. At first, it looks like nothing's happening because you haven't actually started mixing it yet. Once you start mixing it, it's like 90 seconds before it starts to expand hard and fast. So I stir for 45 seconds like fury, scraping the sides. The goal is to whip as much air into this as possible. And then I run into the problem where I've wasted so much time stirring and pouring and trying to get the mold on top that by the time I'm clamping it down, the expansion has already started. I needed something that was going to help me lock it down almost immediately. So I have the mold, I have the wooden donut that evenly disperses the pressure all around the edge so I don't have any warping. And I am on the clock. The foam hasn't really started to do its thing yet. And what I really need to make sure is I have it aligned. So I'm getting the T-nuts all in alignment. Here we go. Now I'm going to start clamping it down. And it's not exactly immediate, but this so far is much faster. I can clamp both sides at the same time. So I really need to do it 8 times instead of 16 individual clamps. But already we have much more secure hold than I would otherwise in the past. And I'm done. I like to reinforce it with the traditional clamps that I have been using. I don't think I need them, but it better to have them and not. Now, remember how I said that the foam is going to come out through the screw holes? I made a little bit of a mistake. I forgot to cap them off. So I'm running away from the camera right now to go grab my box of the little caps. I'll be right back. So I've capped all of the holes except for the vent holes, and now I've put all the clamps on, and I'm just tightening them down to make sure that they are really secure. I like to go snug, not tight, maybe a little bit more than snug. And while I'm doing this, you can hear cracks and creaks and things of the foam expanding and testing the integrity of the mold. It's actually kind of creepy. I want to show you this. So at one of the vent holes, you can see the foam is bubbling and expanding. It's bubbling and it's expanding. Let's see, number 3, there's a little bit in there. Perfect. And number 4, do we have it? Yes, we do. There's a little bit there expanding. So the foam has reached all the way to the edges and it's expanded and it's trying to find its way out. Perfect. This turned out beautiful. Okay, let's address this edge and finish this up. So here's the gap, and this is actually good news because it means the foam did in fact make it all the way to the edge. So great. But one of the things is as I sand, microdust gets in the little pockets of the foam, and it would feel great to the touch until I blew out the dust. And filler primer doesn't really do a good job of filling this in, as I found. So I kept thinking, if only there was a way to keep the dust inside all of the foam and lock it in there. And it turns out there is a way. Okay, so to solve this problem, we're going to go back to West Systems resin, the 105 and the 206 that I was using. But this time, we're going to mix in something called a microlight fairing filler. West System makes this. It's called 410. It's basically just super fine particles. It's made for this purpose of filling in cracks, filling in little gaps and things like that, and making it nice and smooth. Keeping in mind that West Systems 105 and 206 have to be mixed in a ratio of 5 to 1, I'm currently measuring out probably like 10 ounces of the 105. This will give me way more than I need, but at the ratio of 5 to 1, measuring out 10 ounces to 2 ounces is so much easier because it is really hard to measure out 1 measly ounce of the 206. And just like before, we mixed for 2 to 3 minutes. I most likely did 2 minutes because the quantity is so small. I would have felt that I had a really good mix at the 2 minute mark. I wanted to show you what the 410 is going to do to the mixed resin. You can see right here, it has the consistency of like hot maple syrup. And watch what happens when I mix in the 410. One thing to note, look at the size of that container of 410. That is the 5 ounce container. Knowing what I know now, I would have bought the 2 ounce container. But when you look at it on the thumbnail, there's no sense of scale. But that is massive and it is light. That container feels like it is empty. I mean, it's 5 ounces. But now I'm going to mix it in with the resin. Continuing the mix, I actually went and put in 2 more scoops of the 410, and now it's nice and thick. Almost, it's like a paste. It is still runny. If you set it down, you would see it slowly start to run out, but we're getting pretty much where we need to be. This part is fairly straightforward. I just have a craft popsicle stick that I chopped the end off with a pair of scissors to make it nice and flat. And I'm just simply taking some of the paste and rubbing it into the gap. I also want to make sure that I get the vent holes. It's been 24 hours and look how this has cured. I can't even move it. All right, enough of that. Let's sand this back and finish this up. And just for funsies, let me show you how I put the rivets all along the bracket in the back. So after marking where I want them to go, I take the widest drill bit that I have and very slowly, all I'm looking to do is make something of a cone indentation. And then I just take my Dremel with my flat bit and flatten it out. Easy peasy. Just do that about 40 times. And there you have it, one fully completed Captain America shield back. At this point, I'm looking, thinking to myself, 8 more weeks of work and I'll have a Captain America shield. Thanks for watching, everybody. Take care.